Everybody, I'm just giving you some updates on lab number 8 on projectile motion. This lab is not a traditional one. We're using a simulator to help instead of actually doing this at your house. So here, this is the one that's recommended and the lab is written for, but we realize now that this doesn't work for a lot of your devices. So I'm going to go ahead and go through a little bit of a tutorial on how to use this Phet one because there are some modifications that have to be made in the lab to do that successfully. So go ahead and push play to start it, and you'll see there's 4 different options once it gets loaded here. We want to click on this lab one. So there's lots of variables, and if you look at the lab in particular, we're looking at the effective launch angle and launch speed and then air resistance. So we're going to start with no air resistance. And if you look at the lab, I've made myself a couple of notes that we want to get a target out of the way. That's the same as this flag stick. And then we want the launch velocity to begin at 10. And we're also going to make one more kind of silly change, but it's important. So let's go back. We want launch velocity to 10, move the target out of the way. There we go. Let's get that way out of the way. Initial speed, we want it to be 10. And I'm going to make use of the piano, and it's going to be kind of strange, but I'm going to do that because it'll help when we're looking at air resistance in the third part. The other thing that you have to do to get started is you need to drag this tape measure over so that it lines up here with the Canon, and I'm going to zoom in so that I can do that. So I'm going to grab this thing, and I want the crosshairs on the edge of that tape measure to line up with this black one right here. So I've got that all lined up. Now I'm set. So in the lab, we're going to start with a launch angle of 30, and we're going to see what happens. So back down to 30 degrees. So I'm going to go ahead and hit this red button, and it's going to launch that piano. Now, luckily for us, it gives us a point where the piano actually landed. And so you take this end of the tape measure, you stretch it out, line it up with where the piano ended, and we'll see that our distance is approximately 8.99 meters. Now, to avoid confusion, I'm going to get rid of that one so that I can move on to the next, and I'm going for 35. So back here, I'm going to go to 35 instead, and I'm going to go ahead and launch, and we can see that it's gone a little bit further. Okay, so I'll drag that a little bit further, and then I'll go ahead and make that record that data over here, my data table. So this one's pretty straightforward. When you get to the next one, we want to modify only one variable. So we're going to set the launch angle. The launch angle is going to stay the same at 50. And then we're going to start at a speed of 10 is what the lab is written for. I'm going to recommend that you start at 5 instead, because we still want to get enough measurements. And if we start at 5, then we'll have 6 measurements. So here, we're going to switch our launch angle to 50. Okay, I'm going to get rid of this piano, and we're going to start down here at 5. So we're going to launch the piano, measure to see, so move this back, measure to see how far it went. Right there, 2.53, record that in my lab, but notice what I did here is I changed that launch speed. Instead of 10, I changed it to 5. So you're going to keep going, and the last few boxes then, you're not even going to have anything in there. So finally, we want to look at the effective air resistance. So I'm going to come over here. I want to clear out what I have, and I'm going to still stick to using my piano. I'm going to stick to the same speed. I'm going to stick to everything else staying the same, but I'm going to turn on this air resistance button. And I deliberately chose the piano because it has the highest drag coefficient. That means we're more likely to see a difference. So when we click that button and we have the piano launch, then we should be able to measure and see that there's hopefully a difference when you add the air resistance. If you adjust this altitude, then that's actually going to decrease the amount of air resistance. So you want to keep that altitude at 0 in order to get the best difference in measurements between the part 2 of the lab, table B, and table C. So hopefully that's a little bit able to help you. And I see here that there's no place for you to add your selfie. So if you'll go ahead down in here, Add that in there. I know it's ridiculous, but we need verification that you've done it. So add selfie with you and your computer on the simulation. That would be great. So good luck, everybody. Have a good week. Always contact your professor if you have any questions. Thanks.